Numbers are the fundamental language of computers. Beyonce was wrong when she said, numbers. Numbers are important because you can't call a girl without them. We've been working with integers, but we have yet to define them. And if your girl is a 10, she must be defined. You know what I'm saying? An integer is a number that does not have a decimal point or fractional component. It's a whole number. Can't have half of a girl. Integers are typically used to count a number of things. The difference between integers used by computers and all the other numbers out there is that an integer type on a computer takes up a certain amount of memory. Hence, they cannot represent all the possible whole numbers. They have a minimum and a maximum value. You're probably sick of me jabbering, so I'll just show you. So let's do print the maximum int value is /int.max. Blessed. Bring up the console here. Beautiful. Print the minimum int value is /min. Beautiful. What the heck are those numbers in the console? Computers store integers in binary form with a fixed number of bits. A bit is a single 0 or 1. Each bit position represents a power of 2. To compute the value of a binary number, add up each of the powers of 2 whose bit is a 1. For example, the binary representations of 38 and negative 94 using an 8-bit signed integer are as so. So we read a bit positions from right to left and a signed bit integer. And when I say signed, that just means the integer can represent positive or negative values. To calculate this 38, we just go through it. And if it has a 1, we're going to calculate whatever this power is, this position. So since this is the top leftmost bit, this is the only signed integer. This is telling you whether it is a positive or negative value. So since it's a 0, we know that it's going to be positive. 2 to the negative 7 times 0, 0. 2 to the 6th times 0, 0. 2 to the 5th times 1 is 32. 2 to the 4th times 0, 0, 0. 2 to the 2nd is times 1 is 4. 2 to the 1st times 1 is 2. That is how we get our 38. And then here, just to work through this, we have negative 2 to the 7 times 1 is negative 128. This is 0. 2 to the 5th times 1 is 32. So on, so on, so on. And then we have a 2 here, and that's how we get negative 94. Only this position right here, this first guy right here, determines whether it is a positive or a negative value. And the Mac OS, the Mac operating system, int is a 64-bit integer, meaning it has 2 to the 64th possible values. So instead of an 8-bit integer, as I just showed you, it would be 64 bits wide. The power of 2, represented by the top leftmost bit, would be negative 2 to the 63, and that equals the minimum value that we see right here. And if we added up 2 to the 0, 2 to the 1, all the way up until 2 to the 62nd, we would see this maximum value. That is in the Mac operating system. In iOS, it's a little bit more tricky. So since Apple introduced the 64-bit devices, starting with the iPhone 5S, the iPad Air, and the iPad Mini with Retina, before that, earlier devices had a 32-bit architecture. So if you write an iOS application for newer devices, that would be targeting a 64-bit architecture. So int is a 64-bit integer, just like in Mac OS. If we targeted a 32-bit architecture like the iPhone 5 or iPad 2, the int would be a 32-bit integer. Thank the Lord that we don't have to really worry about that because the compiler determines the appropriate size for integers when it builds our program. However, if we run into the issue of needing to know the exact size of an integer, we can always just ask Swift about its integer types. So we could go as far as to say the maximum value for a 32-bit integer is int 32 max. And then we can do this for int 8-bit, int 16-bit, and all the way up to int 64-bit if we really wanted to. So usually we would only use the size integer types when we declare an integer when we need to know the size of the underlying integer, or for it's really common in cryptology and exchanging integers with another computer, like if we wanted to send data across the internet or something like that. That is really the only time we'd have to use this. I doubt that we will ever get into it, but I wanted you to know. So you'll rarely have to explicitly state the specific type, but I just didn't want you to say I didn't prepare you well enough for your interviews. So here are some good tidbits for integers. That's all I have for today's video. Please subscribe, and if that doesn't make sense to to you, feel free to ask me questions in the comments and hit me up on all my other social media. You can do this. You can keep getting through it, keep pushing through it, and I'll see you in the next video.